In this video, we're looking at probability with and without replacement. So in multi-step experiments, so 2-step, 3-step, and more, sometimes the first event can have an impact on the probabilities of later events. So this depends on if each selected item is returned to what we call the data set. So if it is returned, this is known as with replacement. So if you ever see with replacement, you know that whatever happens first, that item is going back into the set after you deal with it, before you move on to the next step. Now, if it is not returned, this is known as without replacement. So that item that you drew out now is out of that data set. So I think the best way to look at it is with an example. So we're going to be looking at this question here. So our example is that we have two cards are drawn from a set of cards numbered 1 to 5 to form a 2-digit number. All right. So what that means is we have 5 cards in front of us, and each card represents 1, 2, 3, 4, and 5. So I'll draw them up just so you can visually see what we're talking about. So we have some cards here. And in those cards we have 1, 2, 3, 4, 5. All right. So we need to find the number of outcomes with replacement. So when we draw that first card, we look at it, we write that number down, we put the card back in, and then we mix it up and draw another card. All right. So to do that, what that's essentially saying is that we have a total of what we call 25 outcomes. And those outcomes can be seen on your screen now. So if I draw a 1, all right, write the 1 down, put it back in, I can draw that 1 again and get 11. I could also get 21, 31, 41, and so forth. So altogether, there's 25 outcomes if I'm deciding to put the card back in. Now, find the number of outcomes without replacement. So if I do it without replacement, what I get is here. I can't have doubles. I can't have 1 and 1 because we've already eliminated that 1. Okay? So what I get here is, so for example, let's say I drew, here's my cards, 1, 2, 3, 4, and 5. And I draw this card here, all right? So I can write that down. Here's my card down here, all right? I no longer have that 1 to draw from. So I only can draw 2, 3, 4, and 5. That's how this is working. So without replacement actually limits the number of outcomes we have possible. So this time we can only have 20 outcomes. Alright, so it's important to read the question carefully to see if it's with or without replacement. And we're going to look at how this affects the probability. So we're going to compare the probability of drawing 31 in both situations. So if I go back up here, there's my 31. So we only have 1. So remember, the probability is what you're looking at, the frequency of what you're looking at. So in our case, the frequency of 31 divided by the total number or total outcomes. So for this one, it's going to be 1 over 20. Now if I go up here to look at with replacement, again, same thing, there's only 131, but that's going to be 1 over 25. So if I go back down here, compare the probability of drawing 31. So probability of 31 with replacement, we said that's 1 over 25. And the probability of 31 without replacement is 1 over 20. So as you can see, without replacement has a greater chance of happening. So remember, when you're comparing things, you're comparing those numbers there. So 1 over 20 means that we have a better chance of it occurring. So again, to recap quickly just what we did, up here, if we scroll up, in multi-step experiments, sometimes things can cause a change in probability later down the track. So if we have an item that is returned to the data set, we know that as with replacement. It's being replaced. Now, if it's not returned, that's without replacement. And it's important to make sure you note that when you're doing your probabilities.